What if you tried to survive on every planet in the solar system? Not with superpowers, not with impossible sci-fi technology. Just you, advanced equipment, and the unforgiving laws of physics. How long would you actually last? Let's run the simulation. Your survival timer starts now. You appear instantly on Venus. Without protection, you wouldn't even have time to understand what's happening. Death here isn't dramatic, it's immediate. The atmosphere alone would crush you long before the heat or acid becomes relevant. So for this test, you receive a reinforced, pressure-resistant suit, titanium structure, corrosion-resistant layers made from tantalum and gold. Enough to give you a chance. Venus is the hottest planet in the solar system. Thick clouds trap heat in a runaway greenhouse effect, turning the entire surface into a planetary oven. Even the night side offers no mercy. Sulfuric acid begins attacking your suit immediately. For a moment, everything holds. Then the cooling system starts to fail. Internal temperatures rise, fast. There's nowhere to hide, no shade, no wind, just pressure and heat. You lose consciousness as your core temperature climbs toward critical levels. Chemical protection breaks down. The suit fractures under stress. Simulation result: you survived 20 minutes, which officially makes you more resilient than most spacecraft that visited Venus. Not bad. Next destination, Mercury. Mercury gives you two options: freeze or burn. You begin on the dark side, where temperatures are brutally cold, but manageable with protection. With no atmosphere to soften conditions, the environment feels strangely silent. Then, the sun rises. It appears blinding white, no atmospheric scattering, no filter, just raw solar intensity. 3 times larger than seen from Earth. Temperature spikes rapidly. Ultraviolet radiation intensifies. Your suit blocks most of it, for now. Cooling systems struggle. Heat accumulates inside the suit faster than it can escape. Night won't return for another 29 Earth days. So yes, waiting it out is not a viable strategy. Radiation interferes with electronics. Life support systems begin failing. Your body absorbs lethal exposure. Simulation result: 15 minutes survived. Mercury, 1. You, 0. Next stop, Mars. You land near the Curiosity rover site. For the first time, the environment feels familiar. Rocky terrain, open horizons, a pale orange sky stretching endlessly. It's summer at the equator. Temperatures are relatively mild. Gravity is weaker than Earth's, making movement feel almost effortless. You walk, explore, adapt. For a moment, survival seems realistic. But Mars has no strong magnetic field. Radiation levels remain high, especially during solar activity. Your suit protects you, but long-term exposure still carries risks. Hours pass without major issues. You could almost imagine building a base here. Almost. Low gravity and radiation slowly begin affecting your body. Cardiovascular strain, neurological stress. Eventually, oxygen becomes the limiting factor. Simulation result: 10 hours survived. Congratulations! You've officially outperformed most of humanity's expectations. But now, we leave almost safe behind. Approaching Jupiter is dangerous before you even arrive. Its massive magnetic field traps intense radiation, forcing you to rely on a heavily shielded spacecraft just to survive the approach. You begin atmospheric descent, guided by data from the Galileo probe. First contact: ammonia clouds. freezing temperatures. Then, pressure increases, temperature rises. Winds become violent beyond imagination. Lightning flashes across the sky like planetary-scale explosions. Your suit survives. Your spine has concerns. Acceleration forces intensify. Control is lost. Deeper, hotter, heavier. Simulation result: 3 minutes survived. You didn't even reach the core. No one does. Next, Saturn. From orbit, Saturn looks peaceful. Elegant rings, soft colors. Inside its atmosphere, it's chaos. You descend through glowing auroras into layers of massive storms. Winds stronger than Earth's worst hurricanes tear through dense ammonia clouds. One small crack in your suit would end everything instantly. Temperature drops rapidly. Electronics begin freezing. Sunlight fades into darkness. Pressure increases slowly but relentlessly. Breathing becomes difficult. Simulation result: 5 minutes survived. Slight improvement. Saturn appreciates the effort. Next destination, Titan. You land on Titan, Saturn's largest moon. Solid ground, thick atmosphere, yellow haze stretching across the horizon. After gas giants, this feels almost comfortable. Gravity is low, atmospheric pressure manageable. Movement is surprisingly easy. You discover lakes, not water, but liquid methane and ethane. Yes, technically you found a beach. No, you should not go swimming. You survive for over an hour, your best performance yet. Then the cold wins. Heating systems fail slowly. Hypothermia sets in quietly. Simulation result: over 1 hour survived. Titan might be cold, but it gave you a real chance. Another gas giant. Extreme cold, violent winds. Simulation result: less than 5 seconds. No commentary needed. From space, Neptune looks calm and peaceful. Reality disagrees. Supersonic winds, freezing temperatures, hostile atmosphere. You begin freefall. Conditions escalate rapidly. Simulation result: 2 minutes survived. Neptune remains undefeated. Not officially a planet anymore, but still part of your challenge. You step onto a frozen desert under near total darkness. The sun looks like a distant star. Light takes over 5 hours to arrive here. Gravity feels similar to the moon. Temperature, minus 220 degrees Celsius. Cold slowly damages your suit until failure becomes sudden. Simulation result: 8 minutes survived. Game over. Every world in the solar system is a different survival puzzle. Extreme heat, crushing pressure, radiation, or unimaginable cold. And maybe that's why Earth remains humanity's only true home. Now, your turn. If you could safely spend 1 day on any world in the solar system, where would you go? Write it in the comments. And don't forget to like and subscribe before the simulation resets.